drain operations. I am happy to report that early this morning we had the core stage drain was completed at about 6 o'clock, just after 6 this morning, and right now we have all commodities off the vehicle. Both stages, both commodities are drained. We are in core stage boil off and inerting activities, and we're getting the pad open back up for control work. So that's a little bit of how the test went. Lori talked about some of the great things that came out of the test. I'll tell you, we had never loaded the core stage or the upper stage from the new 1.4 million gallon hydrogen sphere. We had gone through a complete verification and validation, but we didn't have the hardware to do it with, the flight hardware, and so that went really well. The lessons learned from how we do the sequencers in the software also went well yesterday. Already talked about locks and the CAA. And then the replenish valve. Those of you who were around for Artemis I, remember we had to send a red crew to the pad for the replenish valve, and we made some design modifications on that valve, and it worked flawlessly yesterday. And so that went really good. Lori talked about the breathing air injection that we had for the service module purge, and that was a late mod that we did. Again, worked really well while we had the closeout crew out at the pad, and we were able to do a full closeout of the crew module. So all in all, a very successful day for us on many fronts, and then on a couple of others, we got some work we got to go do. And we're going to go do it. We'll figure it out, and we'll be back here talking to you once again about when we're going to target our next wet dress and the results from that. And with that, I'll hand it over to John.
Thank you, Charlie. Yeah, so this is the first opportunity for us to get the integrated stack for Artemis II on the launch pad with all the systems working together and see it loaded full of the oxidizer and the fuel and get through the countdown operations. It was a great demonstration for the hardware and for the team relative to performance. To me, the big takeaway was we got a chance for the rocket to talk to us, and it did just that. Test gave us exactly what we needed. It was an opportunity for us to wring out the system as well as the team before we ask our crew to go fly on launch day. I'm always particularly proud about the rigor that our teams put into reviewing the data. They stay hungry all the time, and I've been talking to some of them on the phone this morning about looking at data and what we're looking for and just sharing some thoughts there. Going to the MMT was in place ahead of tanking operations, providing guidance to the launch director at our planned checkpoints that included the tanking operations as well as the go for terminal count. We also provided guidance on a couple other points, which I would say were minor risk acceptance items along the way. And that's, that's the big part of what the MMT does is provides risk assessment and approves risk or not. And finally, I'll wrap it up by saying I fully support the agency's decision and the plan we've got moving forward. Rachel, back to you.
All right, it's time now for questions. We'll start here in the room, and then we have several already waiting in our question queue on the phone. Another reminder for those on the phone, you can get into the question queue with *1. And with that, let's start over here with Marcia Dunn.
Hello, Marcia Dunn, Associated Press. 3 years seems like a long time, enough time to wring out any hydrogen leak problems. Why wasn't there more aggressive testing checks since Artemis I? And sorry, I'm just losing my thought here. If you could just explain how you can still be having the same problem 3 years later. Thanks.
Yeah, so in my old job as the core stage or the SLS manager, after Artemis I and the challenges we had with the leaks, we took a pretty aggressive approach, as Charlie mentioned, to do some component level testing with some of these valves and the seals, and try to understand their behavior and their tolerance for surface finish and FOD or debris or scratches or something like that, right? And so we got a good handle on that relative to how we install the flight side and the ground side interface there. But on the ground, we're pretty limited as to how much realism we can put into the test. And then at the end of the day, and what I would say to that is, we try to test like we fly, but this interface is a very complex interface, and when you're dealing with hydrogen, it's a small molecule, it's highly energetic, and we like it for that reason, and we do the best we can. And actually, this one caught us off guard, and the initial things that we were seeing, and the technical team felt like we either had some sort of misalignment or some sort of deformation or debris on the seal.
I would just add that to Marcia's point, we did make some changes, while not to the cavity itself that John was explaining, but we did make some changes to several of the hydrogen components. I talked about the replenish valve. We had a leak there. We did a design mod. It worked great. We also made some changes. If you remember from Artemis I, we also had changes in what I would call the back of the plate, in the purge can and in the debris plate. We changed the flex hose design that comes into the back of that plate. We took the way that some of the hardware was mounted and made it hard welds into the plate. We also took off some of the things that had a cantilevered load. That was some improvements we made during Artemis I, but we did make overall improvements to the ground side of the plate, and we did not see any hydrogen leaks there yesterday. So those two areas were things that were lessons learned from Artemis I that were incorporated, and they tested out really well yesterday. And it was the first chance we got to do that test in this environment.
Okay, we'll go behind Marcia to Bill Harwood.
Thanks very much. Bill Harwood, CBS News, with three very quick but related questions. And I know you can't answer them, but I'm going to ask them anyway. What is the earliest you think you could do another WDR? I know that's an open question. If a rollback is ultimately required for whatever reason, would that rule out the March window? And finally, if the original leak you saw during fast fill, hydrogen fast fill, has showed up on launch day, and you got the tanks filled using your technique, and you never had that problem when you pressurized the tank, would you have been good to go with the original leak, or was that a we're out of here no matter what on launch day? Thanks.
I'll let you answer the last one first. I'll take.
So where would we have been on launch day? If we were able to use our contingency procedures and we had launch window left, and we haven't gone and done the deep dive on all the timelines to see exactly where we would have landed, but certainly if we were within our parameters for launch day, within our allowable 16%, and you had not had the issue when you pressurized during terminal count, you would have been within your launch commit criteria and certainly could have been go for launch.
Yes, I'll take a couple of the other ones there. The first question about the second wet dress rehearsal. We are, a few hours off of completing the wet dress from yesterday. Our teams have a lot of data they need to assess. We need to put together what the plan is and the various tests in addition to wet dress. What else do we want to do between now and then? So there's a variety of things that need to be taken into consideration. So at this time, I don't have a date for when that will be, but we certainly will let you know as soon as it gets scheduled. I'll make sure everybody knows. I don't expect it'll take us too long to get to that point, but we are still in the process of assessing the data that we collected yesterday and developing the plan. We do believe that we do have contingency pad access now available to us, and that it appears at this point that the work that's in front of us can be conducted out at the pad, and that's what we anticipate. I don't know if you wanted to add anything to that, Charlie.
So I would say a couple things, right? During Artemis I, we found out that we can do some work on these plates at the pad. Now, I had hoped that we did not have to demonstrate that again for Artemis II, but we showed that we can go do this work at the pad and be ready for launch. And so that's I would say the first order of business this afternoon when we're done here is for the team to start looking at what that would take and how we'd get into that configuration. Of course, as Lori said, we'll let the data drive us in terms of what the work is in that cavity. But we'll start putting that plan together today. So that's the first part is I think, yes, we can do that out at the pad. The other is that we do have contingency pad access. We developed it for a reason, and that was so that we could do our FTS reset for our clock with the range. And so we have that equipment available to us, and we have it laid into our nominal plan should we need to bridge launch periods between 17 and 18.
All right, we'll go here in the front row, and then we'll go to a few on the phone.
Hi, everybody. I'm James, our local reporter at Channel 6. So given that you're waiting one more month at least until launch, how's the pressure feel amongst yourselves to finally fly the crew, get them around the moon, especially considering the administration wants to land on the moon in just 2 years? Thank you.
Sure. I mean, we feel the pressure to make sure that we're listening to the machine and we're doing the right thing for the crew. I would tell you that we put that pressure on ourselves to be successful, but we don't feel any schedule pressure on this particular subject, specifically for Artemis II, other than the learnings we're going to get from flying SLS and Orion again. There's not, from the production side, there's not particular components that we're waiting on to process the Artemis III hardware. Of course, we're doing major development activities with the lander and the spacesuits, which are, kind of separate from these things, but the Artemis III core stage will be delivered to the Cape. At least the top 4 fits will be delivered here in a few months. We put eyes on the seat command and service module at the ONC. They're in TVAC testing right now. They're ready to be joined. All we have to do is append the new heat shield, which we developed and is qualified and ready to go. So that production activity is occurring separate from the launch activity for Artemis II. However, if we do have learnings from Artemis II, obviously we'll have to cut that into the design. And so we're just we're just doing our normal business, but cranking out hardware for the subsequent flights as we proceed with this launch.
All right, we'll take a few questions from the phone before coming back here into the room, and we'll start with Jeff Faust with Space News.
Hey, good afternoon. Wondering if you could provide a little bit more details about the hatch issue that you reported during closeout activities on the pad last night. Exactly what was going on, and why is the hatch closure apparently a pretty complicated, involved thing that made it one of the top priorities you wanted to check out in the wet dress? Thanks.
Yeah, so I'll comment on that. So the reason we wanted to check out the hatch during the wet dress is just there is limited opportunity to go do that with the integrated vehicle. And we had an opportunity during CDDT for the first time, but the environment's a little bit different being out at the pad. And yes, it's the same hatch, closes the same way, but there's something unique and different about being out at the pad in a cryogenically fueled environment of the rocket that is underneath. And so we wanted to take that opportunity to have the closeout crew demonstrate that. In terms of the complexity of the hatches, there's 2 of them. First off, there's 2 of them to go close out. Folks that were around from Shuttle maybe remember the single hatch and the timelines associated with that. This one's a little bit different because you got to get the crew module hatch closed. You've got to get, Lori mentioned, the purge barrier out, which is it serves as kind of like the name implies, a barrier for that interstitial area, and it's multiple components that come out, and then there's just the closeout of the white room itself. So there's just a timeline and a waterfall of work. I don't know that there's any one thing that is very complex about it. It's just the series of work. And of course, for us, we're always monitoring that work because it does contribute to how long our crew is on their back before we get to T0.
All right, we'll take another one from the phone from Joey Roulette with Reuters.
Hi, thanks. Questions for anyone. I just wanted to re-ask Marcia's question on why this hydrogen leak caught you guys off guard this time. As John Honeycutt said, why wasn't this detected earlier as a possible thing that could come up? And then also I just wanted to get clarity on the Orion closeout work. I know we just talked about the Orion issue, but Jared Isaacman said that additional factors included extended Orion closeout work. And so what is the work ahead on Orion? Thanks.
I'll take the first part. Maybe you guys can do the Orion. Yeah, Joey, it's a good question. As we said, we test the component level, right? And we made the improvements we made from Artemis 1. I think, I don't want to get ahead of the data review, but part of I think what might be contributing to it, and we have to go inspect the seal and see if it was, what condition it's in. But, when we're mated to the tail service mast and we roll, that rollout environment is very complicated, as you see the size of the machine there and kind of the way in which we have to push it out to the pad. So, and while we're rolling, that interface is in communication. And so, we don't really know exactly. It's very hard to predict kind of what credit we can take for and what the acceleration environment is all the way up and down the stack. When we did Artemis 1, in fact, we did a lot of stop and start tests to see if we could characterize it. But even then, it's pretty complicated from a stress and strain standpoint. And so that's not an excuse. It's just that's the first configuration in which we've been able to witness that environment. Lots of times when we look at the duration the rocket can stay at the pad, we have a very good understanding of like onshore winds and those loads and how those affect the mated stack, because that's more predictable. The one thing that's very hard for us and we kind of keep in our pocket as pretty constrained is the number of rolls. Those of you guys that followed Artemis 1, we were very particular about that because we can't take credit for the witness of that rollout environment. It's very complicated. And so we think that's a contributor, but again, we have to tear the seal apart and see what happened. And I'll leave that for the Orion question for y'all.
In terms of the amount of work, if I'm following the question correctly, the amount of work in Orion closeouts for where we were in wet dress, when we were essentially configured for launch, that was always part of our plan because we wanted to limit the amount of work between WDR and our earliest launch opportunity. So in terms of a lot of work within Orion, there really wasn't a whole lot left between WDR and launch. We did have some late stow and some other things, and obviously the final configuration for launch relative to some of the crew equipment. But overall, we were in I would say, very close to launch configuration yesterday.
Okay, we'll take one more on the phone and then come back to this side of the room. The next question is from Eric Berger with Ars Technica.
Hi, thank you very much for doing this. Earlier today, the NASA administrator said of DSLS, the flight rate is the lowest of any NASA-designed vehicle, and that should be a topic of discussion. And so I'd like to ask about that. Going back to the green run years ago, I think that this is maybe the 7th or 8th time the SLS rocket has been fueled, at least the core stage, and all of these tankings have been pretty adventurous. So I'm just wondering, given the low flight rate, do you think launching this rocket is ever going to be more than an experimental process? Thank you.
Well, I'll take that one, Eric. It's a great question. And I think, you're right. The flight rate is not, it's long. 3 years. It was brought up by Marcia earlier. That's a long time between the first test and the second all-up test. Of course, we've been testing across the board, in different configurations. This vehicle is designed to, or at least our test campaign is designed to conduct these all-up tests. We do component and other level testing where we do this tank pressure testing when we machine and manufacture the test. So we do get that data. But, to be fair, it is going to be experimental because going to the moon in this configuration with the energies we're dealing with and every time we do it, these are very bespoke components. They're in many cases made by incredible craftsmen. And so, the geometries of them, even though they're within tolerances, each one of them is different. Honeycutt said earlier, this is the first time this particular machine has borne witness to cryogens, and how it breathes and how it vents and how it wants to leak is something we have to characterize. And so every time we do it, we're going to have to do that separately. This is the configuration that we need, the energies we need in order to achieve these near-term missions. We've been talking with the administrator, at length about this, and he's very passionate about making sure we achieve the objectives of the campaign using this, but also making sure that as we go forward, we try and get to a higher flight rate so we can get more learning. And that is exactly the approach we need, which is why we're pushing for this test for this February window. And we're going to try to, as Charlie and Lori and the guys get ready to go, get another test as quickly as we can.
Okay, let's go to this side of the room. We'll start here in the front.
I'm Philip Sloss. I think for Charlie, just to try and get a little bit more color on what you saw yesterday, with the hydrogen concentrations in the umbilical cavity. Because when we first saw it, we first saw the report, you were up to about 55% or somewhere in that neighborhood. Did you see elevated hydrogen concentration throughout fast fill, or did you see a change near the point where you tripped the limit? And then were you seeing any difference between the flows through the fill and drain line and the bleed line, either in that space of time, or again, you talked about getting into pressurization at T-minus 6 minutes. I assume you get into drain back at that point through the bleed line. Is that what possibly tripped the limit during terminal count?
So let me start with when we saw the leaks. Let me start there. So, what we have learned during the Artemis tanking campaign is that this interface is sensitive to flow rates and pressures. We learned that during Artemis I, and we saw the same thing. Yesterday. It was when we went to fast fill. We were in slow fill. We were within our limits and within our bands. It was when we transitioned to fast fill that we began to see the limits creeping up, or the concentrations within the cavity creeping up. And we did, was it a steady rate? I mean, it increased. We got up to, probably 12, 14%. And then when we got close to the 16%, that's when we did stop flow and revert, and decided to invoke our procedure for letting that interface warm up and then retrying it again. During Artemis I, we found that sometimes that was very successful. I mean, that's a pressure-assisted seal, so sometimes letting it warm up and then putting some more pressure across it, you'll see the seal improve. And so that was the goal yesterday. When we tried it the second time, the performance was pretty similar. We have the ability, and what we do in that case is that we are actually pressurizing in the storage area, in the sphere itself, and we're kind of using that pressure to, hydrogen's light, and so you put some pressure in the system and kind of push it, as we say, push it up the hill. And so we started out with a lower pressure, but as we put additional pressure and got back closer to our fast fill rates, we started to see the leak. And so it was, I would say, in and around the 12 to, when we got up to 16%, we would take action. We saw that through the 3 different contingencies, but we were able to manage it. We would manage it with the pressure, get back within your leak rate in the cavity, or get close to it. And so that's how we managed to get all the way to replenish. In terms of when we saw the spike in the leak, it was in terminal count. It was as we began to pressurize the tank, and whether that came from through the 8-inch or the 4-inch bleed, we really need to get into the plate and take a look, and we'll know more, in a few days when we get in there. So it'd be hard to say at this point. Again, the team's going through the data, so if you ask me tomorrow, I might have a better answer. But right now, I'd tell you that based on the timing, it looked like in real time that it was likely through the 8-inch. Could have been the 4, though. So we'll take a look at all that and see what was going on there. But it did go up, and it went up very quickly, and so we knew that we had something there we didn't understand. That's why the operator immediately gave a cutoff, and we got into safing.
Okay, we'll go to Irene Klotz here, and then Will Robinson-Smith, and then we'll take a few more from the phone.
Hi, Irene Klotz with Aviation Week. I have a question first for Charlie or John. You ended up adjusting the timing for the wet dress because of the cold, but then did the wet dress in the really cold. Can you just explain a little bit about what you were doing during those 2 days, and if there was any equipment or systems that were close to qualification limits because of the cold? And for Amit, did the Falcon 9 upper stage anomaly yesterday do anything for your planning for Crew 12 launch? Thanks.
I'll do the Falcon 9 first, guys, then hand it to you guys. Yeah, thanks, Irene. Yeah, we did. SpaceX did a report as soon as it happened on a Starlink flight that they had an upper stage anomaly. They're working that with the FAA. So I don't want to get in front of that. The FAA is the lead investigative body. We do have our teams with commercial crew embedded in that investigation. And so in terms of how it affects our plans for Crew 12, et cetera, we're pressing towards our Crew 12 window. We're planning towards, just a week, a little bit more than a week from now to start that preparation. But again, that's going to be contingent on the return to flight rationale, which we're heavily partnered with both the FAA and SpaceX.
All right, the 2 days that we delayed wet dress. So let me say a couple things that weren't part of your question, but I'm really proud of the team that worked so hard to get to wet dress early. Right, we looked at what we could do to get there early. Our team had the work done. We were prepared to do wet dress 2 days earlier than we actually did it, and so that actually ended up being a wonderful thing. Now the weather wasn't so wonderful, right? We were in unprecedented cold here in the state of Florida. We were very deliberate about looking at the weather and determining if we were in a configuration to do the test. Originally would have been, our T0 would have been Saturday evening when we ended up doing our call to stations. If you recall, on Saturday evening it was very cold and it was very windy, and we did look at the weather and look at our criteria. The main criteria there for a wet dress, which is different than launch. On launch day you absolutely have requirements for temperature and winds and other things. For wet dress, we did look at our temperatures because we needed to determine if we were within our certification limits for the ground hardware as well as for the flight hardware, and we looked at winds, and winds was really the more concerning item. There was 37.5 knots was what we were looking at as our constraint. And that was the primary driver for when we moved the wet dress originally from Saturday to Monday. And that was a great call, because those of you who were here in the state of Florida during that time, you know that we had 50-plus knot winds on Saturday night. And so that would not have been a good configuration for us to be tanked in. It certainly would not have been a good configuration for us to send our closeout crew to the pad. And so that was part of the consideration for moving it. In terms of how did things go, we certainly saw in some of our, I'll say, pneumatic equipment, right, that is sensitive to temperatures. You know, we saw some fluctuation in some of our regs, but we have as part of the configuration and part of the control on those, they have some automatic or e-reg control that accounts for changes in temperature and pressure, and so we were able to manage all of that. There wasn't anything significant that I would say came out of yesterday, other than, you know, activation of some heaters and those types of things. In terms of protecting the vehicle, we had purge go into the aft skirts during the excuse me, during the cold weather period. Sorry. Sorry about that. We had purge go into the vehicle. We had heaters configured. So in terms of taking care of the hardware at the pad, we had all the right things in place.
Okay, let's go over here to Will Robinson-Smith.
Hi, Will Robinson-Smith with Spaceflight Now. Thank you for taking the time to talk with us. A question first to Charlie, and then a second to Amit. For Charlie, in the blog post that came out sort of summarizing wet dress yesterday, it mentioned that there were troubleshooting issues regarding to audio comms across the ground teams that have been present for the past few weeks, including during WDR. Can you characterize what those were, and are they the same or different than what we're seeing during CDDT in the VAB? And then for Amit, as you're looking towards the future of SLS, bringing in the exploration upper stage, I know the green run is coming up for that in the somewhat near future. Can you talk about some of the planning to maybe nip some of the issues that you've had with the vehicle in the bud for that second version of SLS that's coming down the pike to hopefully make the process to getting to launch a little bit easier? Thanks.
You need a break.
Yeah, you go ahead and then I'll
Yeah,
do
sure.
the
No, it's good. We're looking at the production there for what we're doing at Stennis and how to make those tests more efficient. In fact, we came up with a unique nozzle config so we can do sea level testing of the vacuum engines to make that a little bit better. We'll see how that works. But across the board, we're trying to learn manufacturing fabrication techniques to make that more quick too. I mean, these are big circumferential welds. The diameter is pretty large. We're using a slightly thinner material because we're very mass sensitive there, and so we're learning those things both at Michoud and we're configuring the rigs at Stennis. But I mean, as we go, as we learn every core stage and is a little bit different, right? As was pointed out earlier, it's an experimental vehicle, and just I'm reminded again, for almost 4 days and 40 years from Challenger, nobody sitting in one of these chairs needs to be calling any of these vehicles operational. So, Charlie?
Yeah, so the comm issue that I believe you're referring to is a few days before wet dress, and I forget now exactly how many, but we had a significant comm outage in LC-39 with the ground communication system, and that's the OIS loops that we use to communicate across our teams, both here at Kennedy and then back to our support centers across the country. And so we ended up calling in, I'll say, a suite of experts to go look at what might be causing that outage, and it really ended up being I'll say, a series of events that had happened, and it was within the and I'm probably not the right person to answer this in this level of detail, but let me just say that it was in the kind of the details of the code. It was an edge case where you had a series of events that had to line up just perfect, and they did, and it ended up taking out our one of our LC-39 communication servers. So the team did a great job, pulled in a lot of experts, including the supplier of this equipment and NASA experts from across the country. They did a deep dive on all of this, were able to diagnose the root cause right away, put a series of workarounds in place, and I'm happy to report that the comm worked fine during the wet dress rehearsal. And wet dress and launch are a great test case, because if you think about, when you're doing a single test, you might have a handful, maybe you've got 30, 40 users, but on wet dress day, you've got centers across the country. We're all tied together. You've got hundreds, maybe thousands of users. So there's a big load on the system, and it worked really well. So the team did a great job resolving that issue.
Okay, we'll go back to the phone bridge, and we'll take a question from Micah Maidenberg with the Wall Street Journal.
Hey, thanks, Rachel. Maybe for Charlie or John, could you talk about some of the top items the team did not get to practice with the rehearsal stopping when it did? And do you actually need to get closer to or hit that 33-second mark during a rehearsal before an actual launch? Thanks a lot.
Maybe it's a good honeycat question.
I'll take it. So what are the things that we didn't get to do yesterday that we wanted to do? Well, let's talk about the things that we did. So we loaded the core stage and the upper stage with hydrogen, got to replenish. We loaded LOX, upper stage and core, got to replenish. What are the things we didn't do? We wanted to get through terminal count. We wanted to get inside of terminal count. We wanted to hold, and we wanted to verify our 3-minute hold capability, which is that you've got all of your cryoprop systems in a launch-ready state, and you can hold them there for up to 3 minutes. And we wanted to demonstrate that capability. We wanted to demonstrate a recycle, which is we would go down, have a planned cutoff in the countdown, come back and retarget a new T0 and be able to demonstrate that within the launch window. Didn't get a chance to do that. And then we would come down, do the handoff to ALS, and then cut off shortly thereafter. So I would say those are probably the 3 things that we had intended to do yesterday that we did not get an opportunity to do. And we'll target doing those in the next wet dress.
The next question is from Denise Chow with NBC News.
Hi, thanks so much. It sounds like for now work will be happening out at the pad. But I was curious if you have any early indications yet about whether you might need to roll back to the VAB. And then if you guys need it, are there launch opportunities beyond April that are available?
Yeah, I'll take the first stab at that. As I said earlier, right now it looks like the work that needs to be done can be done out at the pad. So we're gonna assess that. If that changes, we'll let people know. But that's the intent. As far as the launch opportunities, I know we've published what those opportunities and what the available dates are that could be targeted. We publish those for February, March, and April. We've got opportunities in every month, several days. So, if necessary, we'll go beyond that. But yeah, there are opportunities. We do have, as you know, constraints on a variety of different constraints that determine just how many days within the lunar month we have available for launching. You've seen for February, March, and April, it's on the order of about 5 or 6 days. It'll be something similar. It varies month to month, but yes, there are additional opportunities.
Okay, next on the phone we have Anthony Leone with Spectrum 13.
Hello, and thank you very much for taking our call today. With the leak issues that Artemis I and II have faced, will this reinforce NASA's consideration of using a different vehicle for Artemis III, such as Blue Origin's Blue Moon lunar lander, which was something that then acting Administrator Sean Duffy talked about? Thank you.
Yeah, sure. So we are, of course, heavily partnered with Blue Origin and SpaceX and other super heavy lift launch vehicle providers. They're integral to our architecture. So we're going to continue to partner with them and share learnings and implement and cut them into our mission plan. So that's certainly true. Changing commodity on SLS or changing the design in that severe way will probably disable the production significantly. And make a change. You expect a change. We're as discussed earlier. It's hard enough for us to get into a flight-like configuration in a lot of these tests, and so now putting a big design square wave into it, I'm not sure would have the value that we'd expect. What we really want to do is let industry innovate on their own machines, and then when they're ready to support our missions, we'll cut them into the architecture and use them as we need to.
Okay, next on the phone we have Marcia Smith with Space Policy Online.
Thanks so much. Could you tell us how long you can keep the stack out at the pad? And I seem to recall that on Artemis I, one of the factors was you needed to change the batteries on the flight termination system. Is that still an issue this time, or have you found a way around that?
Sure.
There are some batteries with flight termination that will need servicing, but we talked earlier about the pad access that we now have available for Artemis II. That was a lesson learned from Artemis I. So there are some things that we can do servicing out at the pad. I will say that we do have other batteries. For example, the inner cryogenic propulsion stage, our upper stage, that those batteries will need to be serviced at some point. And so that if we go beyond the March time window, we probably would have to roll back in order to access those batteries. That's anticipated right now. So, yeah. Did you want to add to that, Charlie?
No, I think you covered it.
Okay, we'll take one more on the phone and then come back into the room. Next question is from Josh Dinner with Space.com.
Hi, thank you so much. Just a clarification question. You mentioned the quick disconnect. Is that the same component that caused issues with Artemis I? And is it a piece of ground equipment that would have been refurbished or replaced after that launch, or is it the same physical piece of hardware?
So it's different hardware on the flight side. It's same. The major components are similar on the ground side. There's probably some small parts and things like that that get refreshed.
Okay, we'll come back to the room here in the white sweater.
Hi, thanks so much. Jackie Waddles with CNN. A question for Mr. Honeycutt. You mentioned that there were some minor risk acceptance issues that the MMT worked through. Curious, could you give us insight into any of those and how the MMT discussed and what you communicated?
Yeah, Charlie talked about launch conditions versus testing in wet dress conditions. The majority of those were things like purge temperatures being out of limit just a little bit, and that doesn't bother us because those are really what's required to fly. They were pretty minor, but our process drives us where we're violating any launch commit criteria, taking a waiver, or there's risk acceptance involved. Charlie and her team bring that forward to the MMT.
Okay, we'll come on this side, third row.
Yes, Zachary Albert with the Launchpad from Canada. For Charlie, looking forward to the next wet dress rehearsals and then a launch attempt, can you take us through what the limitations are for, if we get into tanking, what the limitations to recycle for another opportunity on another day? Artemis 1, I know we heard 24, 48 hours. Also, looking towards the vehicle, are there any waivers that are maybe approaching a deadline that we'd have to look at? With Artemis 1, big one was the SRBs. Are we approaching any of those cutoff timelines that we'd have to look at some sort of waiver?
So I'll probably invoke the panel for some of the greater waiver pieces, but I will talk about the recycle capability. So we have two things that in a wet dress that we do, and the first is, or the plan was to come through a nominal count, because on a real launch day, one of the things that we can do is that we come through count. We have a 2-hour launch window, provided that you have enough window to do this. If you had an issue where you had a cutoff in the middle of your term count, you have the ability to go get back into fill, get your tanks topped off. If it was something that you could clear, explain, work your way through, and then retarget a new T0. That is not a capability that we had demonstrated during Artemis 1. Thankfully, on Artemis 1 launch night, we came through terminal count without an issue at all and didn't need that capability. But we wanted to demonstrate. We've done it a ton of times in sims. Time and time again, it's part of our normal sim cadence is to go through and do a recycle, but we've never done it with the hardware. So we wanted to demonstrate that. So that recycle is you are coming through term count, you are going back, and you're going to retarget another T0 within that same 2-hour window. The difference when you were talking about the 48-hour scrub that we had, that is our turnaround between launch attempts. And yes, we do have a very different capability this time around. And before, we utilized somewhere between, depending on when you scrub, somewhere between 250,000, 300,000 gallons of hydrogen. We have losses just in boil off, and so you have to replenish that. And during Artemis 1, that was about 30 tankers worth of hydrogen that we had to roll into the pad. We did about 20 hours of replenishment ops, and that set us up for a 48-hour scrub turnaround. That also puts a big demand on the suppliers. That's a tough turn for really everyone involved. So we built the new 1.4 million gallon hydrogen sphere. Again, first time we'd ever used it, we refer to it as our loading sphere, because that's how we intend to load the vehicle, and we use the old sphere to store hydrogen. So when we have a scrub, we can instead of taking those 30 tankers, we can push a couple of 100,000 gallons of hydrogen from one sphere to the other and be ready for the next attempt. And so we do have a 24-hour scrub turnaround capability for Artemis II as a result of that new hydrogen sphere.
Yeah, probably the biggest one you mentioned was the booster. So the booster office does a really good job of staying way ahead of us on when our need is and doing their assessments. So for the near term, we're still good. If we start seeing where we may bump up against that, they'll go reassess. But those assessments have all been positive to date. Some of the other areas you've already heard about, batteries, and then soft good, the Moon to Mars Enterprise does a great job tracking all those life limit items. So I don't see any concern out there right now.
Specifically, I think the cast life is good till 28 on the boosters, I think, for this pair, and then slump. You worry about slump, just propellant grain migration, but we can measure that as we go, so we can actually take a witness and see if we're getting any migration. We're not seeing any of that right now. A handful of other things on the vehicle, on the spacecraft, like the scrubbing capability of the sorbent material and the CO2 beds is also something we watch, but we've checked that through the middle of 27, so we got a lot of margin there.
We'll go back to the phone bridge to the next question from Alicia Stowers with Mashable.
Hi, thanks for taking my question. My initial question was going to be about those ground communication dropouts, but since that's already been answered, I was wondering, just sitting at the pad while this work is being completed, is there increased risk of damage to hardware and electronics on SLS through, exposure to these extreme temperatures and, weather elements?
Take a shot and I'll hand it over to John. So one of the things about having space hardware is, that tank is rated for hydrogen at minus 423 degrees. So when you stack that up against a local forecast of 25 to 27, there's certainly things we take into account as it relates to fly-in. But sitting out at the pad, it's in pretty good shape, especially with the purges on the vehicle. So I think that's, I don't know if you have anything.
Yeah, I mean, when we go through our testing and certification processes, we account for all the conditions that we could experience out at the pad, and even back for Artemis I, when we had the high winds from the threat of the hurricane coming through, we did the assessment and we said, hey, it's safer to stay at the pad than just take another rollback, right?
Cat 1 hurricane, right? So
yeah.
That'll do. We also have lighting protection. All that's we protect for. We don't do it carelessly, but I think the vehicle's pretty robust against those conditions.
We'll take one last question on the phone from Paul Brinkman with Aerospace America magazine.
Hi, yes. I would like, could somebody please explain in this context how the leak threshold is determined? I believe 16% was mentioned. What exactly is the risk of a leak at 16%? Just why precisely the countdown was terminated in that case?
I can take a shot at that, or John, if you want to add.
Yeah, what I would tell you, in the shuttle program, I always had scratched my head about why we had such a low requirement at 4%. We challenged the team to go back and do testing relative to that. These small volumes, I think it helps you to understand where we have these leaks. They're purged. They do have a vent coming out of them. Obviously, at somewhere the leak's concentration's 100%, but when you get a leak, it mixes with the purge and then it vents to atmosphere. So we wanted to understand how these small volumes are operate and what the threat and what kind of energy you can have, and whether you can have just some sort of a small flame front that can't sustain itself, or something much worse than that. And when we did those tests, and it was fascinating to go through the data review with the team and see the imagery that they got. But that's where we got comfortable with this 16% limit. I can assure you we had some margin associated with that too. If you got something else, go ahead.
I was just going to say, we were really fortunate that one of the things that the SLS program, they came up with a test campaign that actually looked at that cavity, the characteristics of the cavity, the purge in the cavity, and introduced, and this was with an outside test agency, that introduced hydrogen to see when you could actually get it to ignite. And at 16%, you could not, and that's what the limits were based on. It was based on test data.
All right, that's all the time we have for today. I want to thank our participants for being here today. We will share more progress on our Artemis blog, so you can stay tuned there for additional updates. And thank you for joining us.